All right, so we are going to do some Lewis structures. So first one we're going to do is this one right here, this pH3. Okay, first thing we have to do is check and see how many valence electrons each element has. So P is in the fifth column. Okay, so that means it has 5 valence electrons. H is in the first column, so that means it has 1 valence electron, but there are 3 of them, so we take 1 times 3 and we get 3. Okay, then we add those together. We have a total of 8 valence electrons. Okay, next we have to find the skeletal structure of the molecule. Okay, so since P only has 1, that usually means it goes in the middle. So we put P in the middle. Then we put H's along the outside. Okay, like that. Then we connect each one of the H's to the P with bonds. Now each one of those bonds represents 2 electrons. Okay, so we have used 1, 2, 3 bonds, so that means we have used 6 total electrons so far. So we're going to take 8 minus 6, and we get 2. So we still have 2 electrons to distribute. Okay, now most elements need 8 valence electrons around them in their Lewis structure. Okay, hydrogen is an exception. Hydrogen only needs 2 electrons around it. So each one of these hydrogens is happy. They have a bond next to each of them, so that means they have 2 electrons around them. Okay, phosphorus, however, is not happy right now. It has 1, 2, 3 bonds, which means it has 6 total electrons around it. So what we have to do is just take these 2 electrons that we still have and put them as lone pairs around the phosphorus. So now the phosphorus has 2, 4, 6, 8 electrons around it, so phosphorus is happy. Hooray. All right, next we're going to do this one here, CHCl3. So first, C has 4 valence electrons because it's in the 4th column. H has 1 valence electron because it's in the 1st column, and Cl has 7 valence electrons because it's in the 7th column, but there are 3 of them, so we take 7 times 3, and that is 21. So 21 plus 1 is 22, 22 plus 4 is 26, so we have a total of 26 valence electrons. Okay. Next, same situation as before, we find what goes in the middle and what goes on the outside. Now, there's 1 C and 1 H, okay? The problem with having H in the middle is, like I said before, H only needs 2 electrons around it. So, H is never going to be in the middle, okay? So, C is going to be in the middle in this case. Now, also, C, if there's a C in the molecule, it's almost always in the middle. Okay, now we put our other stuff on the outside. And I already put bonds there. I didn't narrate that, sorry. But we put bonds and connect all the outsides. So we have 4 total bonds. That means 8 total electrons that we've used so far. So we take 26 minus 8. We get 18. Okay. Now, the hydrogen is happy because it has 2 valence electrons around it. The carbon is happy because it has 8 valence electrons around it, 2 for each bond. None of the chlorines are happy. So we are going to use these 18 valence electrons to distribute electrons around the chlorine. So 2, 4, 6 around that one, that's good. 2, 4, 6 around that one, that's good. 2, 4, 6 around that one, that's good, and that was all 18 electrons. So now we can count to see how many electrons are around each chlorine. So 2, 4, 6, 8, that one's good. 2, 4, 6, 8, that one's good. 2, 4, 6, 8. That one's good too. So now this molecule is good to go. Okay. Now, next we're going to do one with some double bonds. Okay. So we're going to do this one here, number 5. So first thing, carbon, it has 4 valence electrons. Oxygen has 6 valence electrons, but there are 2 of them. So we have 12 valence electrons. So we add those together, we get 16. Okay, now, same situation. Carbon goes in the middle. Oxygens go on the outside. We connect them. So now we have used 4 valence electrons, so we're back down to 12 valence electrons. So now we're going to distribute them around, okay? It's usually best to start on the outside. So we're going to go 2, 4, 6, 8, 10, 12. All right, so we've used all our electrons, okay? Now let's look at the oxygens. Oxygens each have 8 electrons around them, so oxygens are happy, hooray. But look at the carbon. Carbon has a problem. Carbon only has 4 electrons around it, so that's bad. We're going to need to take 2 of these electrons and 2 of these electrons and share them between the oxygens and the carbons. Okay, so what we're going to do, we're going to erase, we'll just do that. We're going to erase those ones and put them as a double bond with the carbon. So now carbon has 2, 4, 6 electrons around it, but so it's still not happy. So we're going to do the same thing with these ones over here. We're going to move those ones and put them on as another double bond. So now carbon has, carbon has 2, 4, 6, 8 electrons around it. So now it's happy. Okay. All right. Last one. We're going to do number 1. Okay. So first we have H that has 1 valence electron. Next we have C that has 4. Oh man, that was not what was supposed to happen. Let's get rid of that. Okay, so carbon has 4 valence electrons and nitrogen has 5 valence electrons. So we have a total of 10 valence electrons. Now, get rid of that because that's not good anymore. Okay, so carbon, again, each one of these only has 1. Hydrogen can't be in the middle because it only needs 2. Nitrogen can be in the middle, but again, like I said before, if you have carbon in the molecule, carbon is almost always in the middle. So we're going to put carbon in the middle. We're going to put H on one side and N on the other side. Then we're going to connect them. So we have used 4 electrons. So 10 minus 4 equals 6. So we need to distribute 6 electrons. So we're going to start on the outside. 2, 4, 6. Okay, so now nitrogen's happy. Nitrogen has 8 valence electrons around it. But again, look at carbon. Carbon only has 4 valence electrons around it, 2 bonds around it. So, again, what we're going to do, we're going to erase these 2 and put it as a double bond. So now nitrogen's still happy and carbon has 2 more electrons. But again, look how many carbon has. Carbon has 3 bonds around it, which means it has 6 electrons around it. So we're just going to do that exact same thing again. Erase another pair of, another lone pair, and then add a 3rd bond. So now nitrogen is still happy. It still has 8, and carbon has 4 bonds around it, which means it has 8 valence electrons around it. So now carbon's happy. And that's all there is to it.